Welcome back to Let's Make a Game, a channel about making computer role-playing games using the free program Twine and the Sugarcube format for Twine. In this video, I would like to address a comment that I got from a user, PJNutting4550, and they wanted to know if it would be possible to have an initiative system where you resolved ties based on an attribute of the characters who were involved in the tie. So the highest dexterity or the highest perception or something like that gets to go first in case of a tie. And yes, that is fairly easy to do. And in fact, I've done a system like that, and that's what I'm going to talk about in this video. So thank you for that request. This little miniature program that I've made, I have saved in the Campot zip file on itch.io. So if you go to the link in the description of this video to download the code, and you want the code for this particular video, it'll be in the Campot zip file. So I've set up a combat here. We have 14 enemies. They're all male, which means they have a sneaky score of low or 1. And I have a, what's the word? I've chosen an influencer for my player character. The player character has, as it is listed here, a sneaky of poor or 0. And we're going to use sneaky to resolve the tie. So we can see that the player character has rolled a total of 5, and there are a couple of enemies who have also a total of 5, enemy number 8 and enemy number 9. And if this works, then the two enemies should beat the player character. So let's have a look. And we can see that, yes, that is exactly what's happened. Enemy 9 and enemy 8 both got a 5, and they are going in front of the player character, who also got a 5. We can do one more example just to make sure. So let's do a scoundrel this time. I'll restart it until we get a combat with a fair few enemies just to... Alright, we've got a tie again. The player character rolled a total of 8, and then enemy 3 has got an 8, and so has enemy 1. But this time, because the scoundrel has a sneaky of high, they should win the tie. They should go ahead of the two enemies that got the same thing as them. So let's have a look. And we see that, yes, that is what happens. The player character goes ahead of the two enemies that got the same thing as them. So that's what it does. Let's have a look at the code that allows that to happen. We don't need any new variables for this. We're only using variables that we've already talked about. But I'm going to re-explain what some of the variables do, because there's quite a lot of them. That it gets a little bit complicated. I should note that we're using the sneaky attribute to resolve ties, and we also used the sneaky attribute to roll the totals to start with. But there's no reason why that has to be the case. We could have used the sneaky total to roll the ties, and then we could have used how intelligent they were. We could have said whoever's got the highest intelligence goes first, if we thought that made sense. To use a different number to break ties, all we'd have to do is just change one particular number when we're looking up attributes. So I did say that the way this was ordered was a bit illogical. I had the page sort initiative, and it would sort everyone out in order. Then it would include break ties, and then after that it had the code to display the final results. And I didn't mention that that didn't really make a lot of sense. I'd just done that because of how the pages were added, and it would make more sense to have printing results as a separate page. So we'd sort the initiative, that would end with an include to the break ties page, and then the break ties page would do what it needed to do, and that would end with an include to a print results page. I would probably have called that page display, but I already have a page called display, which I'm currently not using. So we called it print results, and then that prints the results. So I've done that. I've done that in this program. I've also done it in the main Campot program as well. So just to refresh your memory, we shuffle. We put everyone in a random order first. Then we swap. We swap pairs of characters so that they get into descending order of what they rolled for their initiative. Then we break any ties. We deal with if there's two that have the same initiative, should we swap one or the other. And then finally we print the results. The only thing that's new, the only thing that we need to look at is the break ties page, because we're breaking ties in a different way. You might say, why would we shuffle? Why do we bother shuffling everyone in a random order if we're going to break ties based on this attribute anyway? Well, the shuffling is in case the attributes don't break ties. What happens if we have two creatures that have the same total, or two characters that have the same total, and the same sneaky attribute? Well, if they're both a monster, it probably doesn't matter very much. It doesn't really matter if that monster goes first or that monster goes first. If they're both on the player character's side, it probably doesn't matter very much. But it could matter quite a bit if it was one monster and one character on the player character's side. So we do need some way of dealing with that situation. And that could easily happen because the range of attributes of the sneaky attribute is basically the same. The monsters have a sneaky of 1 or 2, and the characters have a sneaky of 0, 1, 2, or 3. So if we have a warrior that has sneaky of 2, they could easily tie with a female giant mosquito that has sneaky of 2. And if we have a character that's a scientist, they could easily tie with a monster that is a male and therefore has a sneaky of 1. So we need some way of dealing with that possibility, and that's why we still have the shuffle. All right, so let's have a look at breaking ties. So first thing we do is we set Z to 0, and there's a note saying it's set to 1 if anyone changes places. So we've done this before. We're doing it again. We're doing it for the same reason, and that is one run through might not sort everyone out. If we have, let's say we have 3 or 4 characters who all have the same initiative number, well, one set of swapping them might not fix everything. So we have this attribute that keeps track of if anything's changed, and at the end of the run we have a for loop which is here and ends down here, and then it says if Z is equal to 1, include break ties. In other words, run this page again. And if not, if we've gone through everything and haven't made any changes, well, that means that we're finished, and we go to print result. All right, so let's look at the for loop. It's a for loop that goes from 1, and it continues as long as it's less than y2, not less than or equal to y2, and it increments by 1 every time. Y2 is the number of characters involved in the combat, and we are going to be comparing slot Y to slot Y plus 1. That's why we have less than Y2. If it was less than or equal to Y2, we'd be comparing slot Y2 to slot Y2 plus 1. But slot Y2 plus 1 doesn't have anything in it because there's only Y2 characters in the combat. So that's why we only go up to 1 less than Y2. And everything that's within the for loop is also contained within this if. if INI y2 is equal to INI y plus 1, 2. So INI anything 2 is the score that that particular character got. So we're only, all of the other code, we're only executing if we have two characters in slot Y and slot Y plus 1 who have the same initiative score. We can see that that if ends down here. Everything else is contained within this for and within this if. So we have a note here that says X is Y's sneaky score, or the character that's in slot Y, their sneaky score, and W is Y plus 1's sneaky score. So we need to find those two. We find the two sneaky scores, and then we're going to compare them. So we have all this code is for is for finding X, for finding the sneaky score of the character in slot Y. And where we find that is going to be different depending on what is in INI Y1. INI anything 1 is going to be a positive number if we're dealing with a companion, a negative number if we're dealing with an enemy or a monster, and 0 if we're dealing with the player character. So we have if INI Y1 is less than 0, then do stuff for if it's an enemy. Else if INI Y1 is greater than 0, then do stuff for if it's a companion. Else, well, if neither of those things are true, then it must be either, if it's not less than 0 or greater than 0, it must be either equal to 0 or undefined. And the program is set up so that it never will be undefined. It will always be 0, meaning that it is the player character. So let's go through these one by one. First possibility, this number is less than 0 and the character at Y is a monster. So we do this in two stages. I could have done this in one big stage, but it would have been a bit complicated, so I thought it was easier to do it this way. So we set Z2 equals $NME something 1. So let's break that line of code into its two parts. We have NME something 1, and then the something is minus INI Y1. So what is NME something 1? Well, that, if we look at the initialize page, it should have a comment telling us what NME is. Okay, NME Z gives details of the Zth enemy in combat, and enemy Z1 is this enemy's type, as per enemy underscore ATT. So, in other words, this will be a numerical code which tells you what sort of enemy you're facing. Are you facing a male giant mosquito, a female giant mosquito, or a pupa giant mosquito? And how do we know which slot to look into? Well, we get minus INI Y1. And INI Y1, again, if we look at the comments, it tells us that INI Z1 is whoever will act Zth in the current combat round, and if it's negative, then it's enemy number Z. And note that we're using not INI Y1, we're using minus INI Y1. Because this number is a negative number, so we might get, say, minus 5, but minus 5 doesn't mean enemy number minus 5, it means enemy number 5. So we need to turn that negative into a positive by saying minus that number. So, in short, that will give us the type of the enemy that we're looking at, and then we go to enemy underscore ATT Z2 3. Z2 is the number that we got up here, and let's have a look at enemy underscore ATT. Well, that stands, of course, for enemy attribute, and we look at whatever slot we get from Z2, and then we look at slot 3 because that's where the sneaky attribute is. If we wanted to look at a different attribute, if we were looking for smart, for example, we wouldn't use 3, we'd use 2. But in this case, we're we are indeed using sneaky. So we use number 3. So that gives us the sneaky score of a monster if a monster happens to be in slot Y. What happens if they're a companion? Well, this code is actually almost exactly the same. The only difference is that enemy becomes COM, which stands for companions, and enemy underscore ATT becomes ATT underscore PER. And we don't use minus INI Y1, we use INI Y1. Because in this case we're dealing with a positive number. So COM is the array that keeps track of the types, or keeps track of the details of any companions you might have. And at the moment we're only using one slot, we're using COM-Z1, and that gives the type. We'll probably use another slot for hit points, but we're not up to that yet. So we're doing this basically the same thing, except we're getting the type from the COM array, and then instead of enemy underscore ATT, which is the enemy attributes, we look at ATT underscore PER, which is attributes by persona. Persona being the word that the person who wrote this game uses for the equivalent of character classes. So we'll be looking in here, and let's say we get a value of 2 because the companion is a scientist. We look at 2, 3, and we see that they have a sneaky score of 1. Again, if we wanted to use a smart score or something else, we'd just use a different number to 3. And then the final possibility is that the character is the player character, and then we look at ATT PER, so we're looking at that same array, but we already have an attribute that is what persona the player character has chosen, and that's PER. So we just look at $PER3. So we might say, okay, PER is 3. That means that they're an influencer. The influencer has a sneaky score of 0, which is the equivalent of poor. And that's what we'll use to break ties. And in that case, of course, they would lose any ties because the enemies all have 1 or 2. Okay, then we have another bit of code which is exactly the same. This is exactly the same code as this. It's just that instead of INI Y1, we use INI Y plus 1, 1. In every case where we have $Y, we have instead $Y plus 1. And instead of storing values in X, we store them in W. So everything we've done for slot Y, we do for slot Y plus 1. And instead of storing it in X, we store it in W. Then we've got W and X, we need to compare them. And we've seen this code before, it's the code for swapping. We set Z equal to 1 so that we know that we have swapped at least one pair this run through. And then we do this code which swaps all of the values between INI Y1 and 2 and INI Y plus 1, 1 and 2. And when do we do that? We do that if W is greater than X. In other words, if the initiative score of the character in slot Y plus 1 is... Sorry, not if the initiative score. If the sneaky attribute for the character in slot Y plus 1 is greater than the sneaky score for the character in slot Y. And why would that necessitate a change? Well, because remember that low numbers are better. 1 is whoever gets to go first. And so Y plus 1, that character acts after character Y. But if the character in Y plus 1 has got a better sneaky score, well, that should break ties. So we need to swap them. And then we close off the ifs and the for loop. And then, having looked through everything, we say, well, did we swap anything? Yes, let's just do it again, just to make sure that we have got through everything. Or no, we looked through everything and nothing needs swapping. Well, that means it's finished. And we print results, which I haven't changed for this version, so I won't show you the code there. It just prints out who's acting when. And so that's how we resolve ties in initiative, by saying that whoever's got the the best sneaky attribute gets to go first, and otherwise it's, if that still doesn't break the tie, then we just do it randomly. And so that is initiative. I've spent several videos talking about different ways to do initiative, mainly different in how they break ties. Unless anyone has any other requests, I will be moving on in future videos. We've got everyone set up in what order they're going to act. Now we need to look at how we do those actions. How do we have the monsters act, which of course will be resolved by the computer program, or how do we give the player choices as to how they're going to get their player character to act, and what are companions going to do? Are they going to sort of do what the player character orders, or the player orders, or are they going to sort of do their own thing, or what happens when they're, which is a little bit complicated. There's sort of roles to see whether they do what you say, basically, just to preempt that. But for now, I hope that was useful or interesting to at least some of you, and I hope you will tune in next time.